Hello. Today we are going to talk about how to use the order of operations in mathematics. So order of operations. So different arithmetic operations have a different order of importance. You can't just simply do everything as you see them. There is a certain pattern, a certain order to what you must actually do. And to evaluate this numerical expression, you have to, again, correctly complete the problem in the proper order. So step one is you evaluate the expressions inside your grouping symbols. Grouping symbols can be a set of parentheses, like that, a set of brackets, or it could be a fraction bar where you have some expression up top and some expression on the bottom. Those are all considered your grouping symbols. So you need to evaluate those first, and then you evaluate your powers. So your powers are your stuff like your exponents. So like 5 squared, for example, you would do before other operations. Power symbols also include your square roots, so like the square root of 4. Because technically a square root is really another power, and we'll learn about that in a much later lesson as we go on. After our powers, we either multiply or divide as you go from left to right. They're considered similar operations, so you don't do multiplication first and then division. You don't do division first and multiplication. It all depends on the order they show up in. For example, if we have something like this, 8 divided by 4 times 3, we don't do the 4 times 3 first, we do 8 divided by 4, because it appears first as we go from left to right. So you do 8 divided by 4 and get 2, and then 2 times 3 is 6. So that's important to remember, especially because the common way to remember order of operations is what we call PEMDAS. Parentheses, exponents, multiplication, division, add, subtract. That's step 4. And the reason why you have to be careful with this, well, this is a very useful way to remember it, especially when you need to consider, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, add, subtract. It is kind of misleading because it makes you think like you do always parentheses first, and then exponents, and then multiplication, and then division, then add and subtract. Multiplication, division, and addition, subtraction are similar operations to each other, so that's why you do them first as they go from left to right, not as you first see a multiplication symbol or first see an addition symbol. Okay, so let's do some examples. So we can use our PEMDAS order of operations to evaluate. So we have 16 minus 8 divided by 2 squared plus 14. So we'll take a look at PEMDAS, parentheses, I don't see any grouping symbols here. There's nothing to worry about. Next, exponents. Well, I have an exponent here, 2 squared. So this becomes 16 minus 8, and then divided by 2 squared is 4, so divided by 4 plus 14. There are no other exponents, so we're done there. Now multiplication, division. Again, they both occur at the same time as you go from left to right. Well, I only have one symbol like that, division. So 8 divided by 4 is 2. So you have 16 minus 2 plus 14. And now we have no more multiplication division symbols. Now we move to the last step, adding and subtracting. So I have 16 minus 2 plus 14. Subtraction comes first, so I do it first. 16 minus 2 is 14. Then 14 plus 14 is 28. Notice you've had a completely different answer if you had tried to do addition first, thinking A before S. You would have instead said 2 plus 14 is 16, and then 16 minus 16 is 0. Completely different answer. Would have been horribly wrong. Okay, so the answer for that one is 28. Next one, 3 plus 42 times 2 minus 5. This one's a little bit simpler, less going on. We don't have any parentheses or grouping symbols. We have no exponents, so we go on to multiplication first. So 3 plus, well, 42 times 2 is 84, minus 5. So now we're down left addition, subtraction. Add first, because it appears first. 3 plus 84 is 87. 87 minus 5 is 82. And there's our answer. 4 divided by 2 plus 5, parentheses 10 minus 6. Now, if there's a number outside parentheses like this is considered like an invisible symbol. It really means multiplication right there. Come on, there we go. So once we figure out this result of the parentheses, we're really doing 5 times whatever that number is. But again, parentheses come first, so we do the inside, 10 minus 6. So 4 divided by 2 plus 5, and then parentheses, 10 minus 6 is 4. Again, we now do there's no exponents, we now move multiplication division. I do as I appear first left to right. 4 divided by 2 is 2. And then 5 times 4 is 20. And then finally, 2 plus 20 is 22. Now this one is a little more complex because now we have 2 different grouping symbols. We have our bracket grouping symbol and then parentheses inside that. The thing about the grouping symbols is, if there's a lot more going on inside there, you need to do PEMDAS in the proper order inside your grouping symbol. Here we didn't have to worry about that, there was only one operation. Here we have subtraction, we have adding inside our grouping symbol, and we have an exponent. But again, we do all our grouping symbols first, so inside the first grouping symbol is another one, so we do 2 plus 3 first. So we have 6, the bracket 32, minus, well, 2 plus 3 is 5, so minus 5 squared. Now, still further inside our grouping symbol, we have an exponent. That comes before subtraction. So I do 5 squared next, and 5 squared is 25. And now the last thing to do inside this grouping symbol is subtraction. 32 minus 25 is 7. Now we have just 6 bracket 7, which means 6 times 7. We have our invisible multiplication symbol. And then 6 times 7 is 42. So there's our final answer there. Now we have our other grouping symbol, the fraction bar. So what we're going to do is we can't cancel like the 15 and the 5 across each other like that. That's not how it works. Or like this 3 to the x1 with the 9, can't do that. What I have to do is I do everything up top first, and everything on the bottom, and then once I've fully done that, I now have a fraction. I can see if I can simplify it. So up top I have an exponent, so I do that first. So I have 2 cubed, which is 8, minus 5, over 15 plus 9. And again, up top, we'll do that part first. 8 minus 5 is 3. So I have the entire top simplified. Let's now simplify the bottom. 15 plus 9 is 24. So I have 3 over 24. So I have now my fraction 3 over 24, top and bottom both fully simplified. But now I need to simplify the overall fraction if I can. And I notice both top and bottom are divisible by 3. So if I divide top and bottom by 3, I get the fraction 1/8. And that is now the fully simplified fraction, the correct answer to this expression. If you had left it at 3 over 24, your answer would be correct, but not 100% correct. It would just be mostly right. And it is always considered proper mathematics to simplify your fractions as far as possible, whether they're simple numbers or more complex rational expressions, which we'll get to at a much later date. So what I want you to do now is, I want you to solve these problems on your own to test your knowledge if you can do PEMDAS correctly. I'm not going to work out the solutions for you, I'm just going to provide the answers for you. So make sure you go ahead and pause the video so you can have time to work it out, and then I'll give you the answers. Alright, you should have gotten, for the first one, 0, the second one, 10, and the third one, 1/9. If you didn't get those answers, please try them again. If you're still not getting those answers, it is entirely possible I made a mistake, however unlikely. Feel free to contact me and I'll take a look at the problem again. Alright, so that concludes our... Oh, sorry, one more problem. So sometimes you'll see these problems in word problem format. So for example, the admission prices for SeaWorld is $80 for an adult and $50 for a child. You want to write and evaluate an expression to find how much it costs for a group of 4 adults and 7 children to go to SeaWorld. Now, I have no clue if these are the actual prices. I just kind of made up ticket price numbers. So what we're going to do is, well, the cost to go to SeaWorld will be 4 times whatever the cost for adults is, plus 7 times whatever the cost for the children is. Well, adults are 80, so it's 4 times 80. Children is 50, so it's 7 times 50. 4 times 80 is 320. And then 7 times 50 is 350. And when I add them together, I get 670. So apparently, according to this word problem, if you had 4 adults and 7 children, it would cost you $670 to go to SeaWorld. Probably not that much realistically, but again, I just pick numbers to make the problem work. Alright, and now that concludes our video. So stay tuned for more videos. Again, this is for an Algebra 1 class. Feel free to leave comments for me, and hope you enjoyed it.